So now that we're done talking about the server implementation of our PrimeCheck app case study, let's focus on the structure and the functionality of the client. And again, we're doing this because this will teach us things that are useful for writing Spring clients if you're doing proxies by hand. There are other ways to write proxies that don't require doing some of this stuff, but this particular set of examples is cool for a variety of reasons, as we'll see. So there's a set of classes, the PCClient classes, we'll see what all they are, that perform the client side of the client-server communication. And what they do is they're going to synchronously invoke remote methods on the controller in order to determine the primality of large integers. And you can see that in the PrimeCheck client class. And there's a bunch of different parts here. First, we make this thing a component, so Spring can auto-wire it. We want it to be able to auto-wire the proxy. And even though there are several different variants of the client, one for structured concurrency, one for parallel streams, one for completable futures, and so on, they're all going to share the same proxy. And you'll see how that works in a second. And that proxy is going to be auto-wired. We want to auto-wire that proxy in, so we don't have to manually provide the constructor. There's two methods used in the client. One is called test individual calls, and it's going to go ahead and take in the prime candidates to test and a Boolean parameter. And then the other one, is going to be called test list call. It's going to pass a list. So the first thing you're going to see is when we do the testing of the individual calls, you're going to see that we're going to decide whether or not we're going to be doing this in parallel or whether we're going to do it sequentially. So you can pass that parameter in. And then down here, we're going to go ahead and invoke operations on the proxy to do, in this case, check if prime with a single prime candidate. Sorry, a list of prime candidates. That should be an S. And it's going to go ahead and pass in the type of requested concurrency strategy as a parameter. So that would be parallel stream, structured concurrency, completable future, and so on. This model, where we pass in the list, has the server do all the concurrency. Any parallelism we request, or concurrency, I'm using those terms interchangeably here, is going to be done by the server, not by the client. And then you can see we do this remote method invocation using the proxy that we'll talk about. And the result that comes back will be turned back into a list. So we'll get back a list of integers with the results. There's also another method, which is kind of interesting. This is different from what we've seen before. This one is called test list call. Wait, did I do that right? Yeah, that's right. And so what this does, let me just to reiterate this real quick. This particular example is going to go ahead and make all of these individual calls in parallel. So we're taking each item and we're passing that item one at a time. I mean, whatever is called here, it's going to go ahead and make the call, and that's going to then go ahead and take the list of prime candidates and pass each one of them in parallel over to the client. So the key point there is that the client is doing the parallelism, not the server. There's another variant where the server does the parallelism. So in that particular case, we're going to pass in the list of prime candidates, and it's just going to get forwarded on to the server, which will do the actual computation. So here, the server does the parallelism rather than the client does the parallelism. So let's go ahead and take a look at the proxy class. It's really quite simple. This should look very familiar to you by now that you've done some of these yourself. So we have a proxy class, which is going to be a component, so we can auto-wire it. We have the auto-wired REST template. The REST template is the means by which the client can contact the server and get it to do various things at the right port numbers and so on. And then we have check if prime and check if prime list. This one sends each item one at a time, assuming that the client is doing the concurrency, and this one is going to be sending them all in one fell swoop, assuming that the server does the concurrency. This is the code that implements this. This, again, should look very familiar to you by now. I'm going to go through it, though, because some people are still struggling with how to do this mapping. It's really simple once you know the trick, and you need to take a look at the examples in class because they show how to do it. So here's the one where we're going to go ahead and basically send one item over at a time. So we use the URI component builder. We're going to pass in the path here, which is going to indicate that we're calling the checkIfPrime router method in the controller. We add the strategy as a query parameter, and then we add the prime candidate as a query parameter. So we have 2 query parameters. Those will be encoded into the URL. And then we build it, and we make it a URI string. When you watch the frequently made mistakes video from last class, you'll notice some people forgot to put the build call, and some people forgot to use toURI_string. You have to use toURI_string, not toString, because toString doesn't encode it in the right way, especially if you have funky things in your URIs. And then after we do that, we use our web utils make get request. This doesn't make a list, it makes an individual request. So it uses the REST template where it gets the IP address of the server, uses the URI that we just built up here, and then we say, I want the result to come back as an integer, please, and make get request does that for us. Here's what check if prime list does. It's a little different. It, of course, passes in the name, the router name of check if prime list. It encodes the strategy as a query param, and then it encodes the prime candidates query param by wrapping it up in a list. So it takes the list of integers and it converts that to a list that's a string. So it encodes the list of integers into a comma-separated string, which is going to be encoded in the URI portion of the URL. Make sure you do that when you do your assignment, otherwise strange things happen. And then we go ahead and put the prime candidates. Sorry, what did I do that? Is that right? That should say parallel. Sorry, that's the typo. Query param, the last one should be parallel. So you put the parallel parameter in there. And then we build that and make it into a URI string. So this is the important thing. Now, for your implementation for assignment 1B and assignment 1C, you have to do a little bit more than encode the list to a string. You also have to first encode the regular expressions into a format that can be passed across a network as well. So there's a few extra calls. But you can see what it basically does. This call here essentially encodes the list into a comma-separated string. Now, just be aware, by the way, if we were to have a really, really large URI list of integers, we probably wouldn't want to use a GET request because that would make a gigantic URL that could be too long. So in that case, we would be likely to use a POST request. And because POST requests actually send the contents in the body of the message as opposed to encoding them in the URI. And we go ahead and make that call, and I kind of write out to show you what it looks like under the hood. So localhost 8081, check if prime list, question mark, then you've got the strategy followed by the prime candidates followed by parallel equal true. So that's the end of the overview of the structure of the client, which looks a bit like what you're doing for your assignment.